Let me just explain the concept of live variables, live variables once, because I feel that with time I might forget this thing. So it's better to make a video so that I can refer to it later on. Okay. Now, first of all, what is the intuition between the concept of a live variable? Okay. Now, the main thing is that suppose if you want to with work in a program, if you are writing a program and it is transferred into machine language, okay, now the processor works best when all the operands are in the registers. Okay, so what it shall do is that means all the working variables are in the registers. So to be specific, so means whenever an ALU operation is being done, if its operands are present in registers, then it shall easily be means the operation can be done very easily. Okay, so that being said, what is the usual attempt is that what the usual attempt is that the variables which are defined in our program, they are actually stored in registers. Okay, now when they are stored in registers, uh, means see in the CPU, the registers in the CPU has a register file, and this register the registers in CPU are at premium. Okay, means there is not much. If this is a CPU, there are register. This is the register file. There is not much. There are not many registers available. Okay, so we cannot just allocate registers to all these registers for all the variables. There shall be need when we need to. Uh, we actually need to use the variables, use the registers more efficient, right? So, since the registers are at premium, so we cannot just allocate all the variables which are there in our program to registers. Okay. So what we actually do is that when a variable, suppose v as a variable v has served all its purpose, what we do is that the register which it was occupying, okay, suppose this is the register R1, it was occupying, we can override this value with something else, okay, without the need for copying it back to the main memory. Okay. Now it might be possible that the variables which we are having with us are too many, and the registers which are there are too less, which is mostly the case, and it might happen that the variables which we are having are all live. Means now I use the term live here for the first time. So what does live mean here? Live means that a variable, means once a variable has been brought into the register, okay, it has not served its entire lifetime of this bringing into the register. Okay. What does that mean? It means that suppose if I am having a program, okay, now say I am having a program, say int v, I have declared it here with say 9. Suppose I write something to it. Suppose x is defined somewhere else. Okay, I do x plus 1. Okay. Now, or something like this we are doing. Okay, let me rather assume it in something in a different manner. Okay. Rather than assuming that the variable is being written to the very beginning. Let me assume that x is a variable. Okay, and we are using the value of v. Okay, in x. We are using it. Okay. Now, when we are using it, what we shall do is that we shall bring in this value of x in this register, okay, R1, currently contains the value of v, and we are using it to calculate x. Suppose we have something else, some other variable y, which is say calculating something else. Again, we shall require the value which is stored, of the variable which is stored in R1 here. We have already used it here. Again, we might require somewhere else. Suppose down the line here, suppose there is a variable z, and we are using it here. Suppose we are using it something like this. Okay. Here also we are using the value of variable b, which is stored in the register. So in between here, I am assuming that no one is writing anything to means the value of variable b is not being written to this. Value of variable b is not getting changed. Okay. This is not happening anywhere. So what is actually happening is that when we are loading this value of variable v into this register, then we can use this when we are using it. Okay, we can keep on using it. Okay, now at this point, say suppose beyond this line, okay, there is no use of v beyond this. Okay, beyond this there is no use of v. That means what we can do is that we can simply means suppose we need some more variable to store into a register. Okay, we need to allocate a register to a variable. Suppose say the variable is a, and we want to allocate this means store the value of this register means variable a to some register for our purpose. Okay, now suppose we are not having any free variables with us. Okay, free register with us means all the registers are having some values. Now at this point, since variable v is not used anywhere down the line, so what we can do is that the register r, which is holding the value v, what we can do is just overwrite this value and store a here. Why? Because since this beyond this point variable is no longer used, okay, there is no point in keeping that value. Okay, so what we can do is that we can overwrite this value and store it in the register r1. Okay, so technically speaking, what we are doing is that beyond this what we say is that beyond this point we say that the variable v is no longer live. That is the concept of liveness, which this is the crux, this is the concept of liveness. What does it mean is that as long as a variable is having its use in the program, okay, means suppose means a variable means not the exact variable, means the value of that variable is having a use in the program. To be more specific, see here beyond, I am assuming that nowhere here there is any other assignment to v. Okay, means v is having the value 9 everywhere down this line. This is 9, this is 9, even this is 9, everything is 9. So what we are actually doing is that we are using this value of variable which is there in the register, and down the line we are using it. Okay. So as long as v is having this value 9 and it is having some use down the line, at a point we are having a use down the line, say that variable v is live at that point. Okay. Now this being said, this is an informal intuition. Okay. Now specifically if we see the definition of liveness, suppose let me change the color. Suppose this is a point in a program, we say this point is p. Okay, now we say that a variable, suppose x is a variable. We say that this variable x is live at this point p. If there is a path in the program, suppose there is a path in the program down the line, okay, down the line or whatever, there is a path, there should be a path in this program such that there is a statement J, okay, such that there is a statement J which is using this value of x, okay, and what is happening is that in between means it is using this value of the variable x, okay, means to be specific, it is not just using this x, it is using this value of x, which means in between, which means here whatever, here there is no change to this value of the variable x, which means what does it mean is that just as I have said here, so the variable is live at this point, uh, because as I have said, I don't think if I explain more I should over explain nothing. So let me just say, suppose we are having a program, something like this. Say x is a variable which is assigned a value, say 1 here, okay. Now y is a variable, okay, which is using x is being copied. Now again, say z is a variable which is using x. At this point, say x is storing the value, say 2 times z, okay. Now x, say a is a variable which is storing the value, say 2 times x, and say b is a variable which is using the value, say x plus 1. Okay. Now this is a sequence of statements. So how, at which points we say that the variable x is live? I am talking about the liveness of x. Okay. Suppose before this point I don't know whether x is live or not, means what is the thing which x is holding. So at this point, at this statement, what is happening? Whatever was the old value of x, okay, I don't know whatever it was, means might be something was there here and something is there beyond this. Okay. Now whatever old value was there, that is being replaced by the new value of x, that is 1, okay. So what we are saying is that the old value, if it was, is now no longer needed. So that if x had a previous definition somewhere here, say x equals to 20, that previous definition is being killed by this x equal to 1. What does it mean is that suppose suppose we had a register which held the value x, okay. Suppose this is register R1 and it held the value x which was 20, say. We are doing some work here down the line. Now certainly when x equals 1, this value of x which was 20 is no longer needed by us. This is a stale value and sort of no use to us. So what is the new value of x which is useful to us? That is 1. But the old value of x which was 20 is dead. So that is, we see, is this new definition, okay, kills the old value of x. This old value of x is killed, okay. Those are double ticks. They might look like something else, but they are double ticks. Okay. Now what? Now we say, okay, now at this point we are having uses of this variable x. Okay, so at this point it is worthwhile to store this new value. Suppose this is the variable, this is the register arm, and it is storing the value x, value of x, and it is 1. Now what we are doing is that when we see here this x, this value of x has a use here. Okay, so we say that x, the x value has been used here. Okay, now similarly this x value has a use here. This one, the x equal to 1 has a use here. Similarly that x equals to 1 value has a use here. But now up till this point they had uses. Okay, so if I say that now going into this point, see, now x is getting replaced by a new value, that is z times z. Now what is happening at this point? So z was having a value here, it is 2, and this time x is having a value 4. So that old value which was 1 is getting replaced by x equals to 4. So what is happening again is that the old value which x had, old definition, this one, this definition is getting killed by this new definition. So the this life part, the thing is the x which was at life at this portion is no longer live beyond this, means this is a new scope, means this is a new portion of x and this is actually new x. Okay, so that old x gets killed here, that old x gets killed here, and a new x comes to life from this point onwards. Okay, now see here we can again as usual store this x in some register, that register arm. Okay, and have this value say 4, like this. Now usually when we do data flow analysis, okay, at that time we actually see there using data flow analysis we have blocks. Okay, means basic blocks, we have basic blocks, and there what we do is that we find the variables which are live and outside the block, means just while entering the block, means in set. Okay, in set, and when and we find the variables which are live just outside the block. Okay, just outside the block. Yes. So what we actually do is that, so means a basic, if you know what is the basic block, okay, so basic block shall be not inside, means a statement shall not cut a basic block, means this shall not be a statement like this, means a part of the statement is inside the basic block and a part of the statement is outside the basic block. Okay, that is not possible. So when we are doing data flow analysis as per this concept, okay, we always do liveness analysis, means with that context we do liveness analysis always before a statement and after a statement. This is how it is done. Okay, so means, and about the concept of liveness analysis at a point in that, means when the point is after a statement, before a statement, these points are quite easy. Now when this point is on the statement, means the point is the statement as such, that time we need to be a bit careful, but I shall go into this very quickly. Very soon I shall be going to it. So next, what, see, now let me just give a brief idea of how it works. Now suppose at this point, okay, suppose at this point we, we suppose this is use of variable x, say not x is not assigned a value. We say that some variable a is being assigned a value x. So at this point, okay, beyond this no assignment of x is there. We can say at this point, okay, this is just above this statement. Okay, we say that at this point the variable x is live, because if we are having the value of x equal to 20 here, it shall be used after this, means that we are having a value of x equal to 20 into stored into a register, we are at a profit. Okay, this is the thing which is being said. Okay, you can assume it like that. Now this value of x is used here, so it is live at this point. Now at this point, say it means this is above this bar, means after this bar, means within these two bars which are shown horizontal bars, only a equal to x is the only statement present. Okay, nothing else is present there. To be more specific, suppose this is a basic block, okay, and it is containing only one statement, that is a equals to x. Okay. Now if we see, if we go outside this block, what is happening here? This x, okay, this x which we were having is no longer useful, is useless to us, because the very next moment, okay, I'm showing just as a basic block here, because it might be so that the basic blocks are not constructed in this manner, which it might be so, but this is just hypothetical. Now just beyond this, that old value of x was having no use. So here we see that this variable x is killed here. This is the value x is no longer live. Why? Because just here we have redefined x, means redefined x. What is x? Means x is equal to 1. We have done again. So the previous value is no longer useful here. So at this point, x is useless. Okay. Now again, if you see at this point, x is live. Now what is x is live, and what is with respect to this new value of x? Okay, why? Because we are using this value of x here. Again, if we see at this point, again here x is live, and we are using this with respect to this. Okay, with respect to this, x is live. But here again, if we see at this point, x is no longer live, means when we are drawing this line, okay, this horizontal line, we are seeing with respect to the bottom. Okay, with respect to the bottom, we are seeing at this point x is no longer live. Why? Because here there is a redefinition of x, so the old value of x gets killed, so that previous x is no longer live here at this point. Beyond this point, means just after this point, means just after this statement. Okay, at this line horizontal bar after this statement, it is as shown. Now again here we come here, at this point x is again live. Why? Because there is a use of x here, and which corresponds to the variable 4. Okay, means this use of x, means this new definition of x. Again here again x is live. Why? X is used here. So now assume that beyond this point, means now here if we see, x is no longer live, because as per our assumption, this is the last usage of x. Beyond this, no longer there is nothing. There is nothing in the program which uses x, defines x, or uses x, something like that. Beyond this, there is no story of x in this program. So x has no use here. So x is x is not live. Okay. Now let me consider the situation where we are analyzing the liveness at a particular statement. Okay. Specifically at a statement, not after a statement or not before a statement. Okay. Specifically and a particular statement. Okay. Now this being said, see, now let us get the idea, and then we shall go to, through the entire thing. What is happening here is that, see, suppose x is defined here. Okay, see, x is defined here as a new value. Means a new variable means a constant value is being used to means define x. Okay. Now, if we see this point, means leaving that apart, if we see this point, means this statement, what is happening? At this point, x is live because we are using the old means the old value of x is being used here. Means old value of x is being used here, so x is live here. Okay. Now, at this point, means at this point, what is happening? This old value of x is no longer useful here because x means the old value of x is not being used here and x is being replaced here. Okay. Now what is happening? This x is not live here. Okay. So at this point, why? Because the old value of x is being overwritten here. Okay. So this definition of x is this writing back of new value of 1 to x is killing the old value of x. Okay. Now at this point, x is killed. Okay, means x is not live. Old value of x is not live. But the new value of x is not having any use till now. Is at this point, is beyond this point there is use. At this point, x is just having is assigned a new value. The old value has been removed. Okay, so at this point, x is dead. That old value of x is dead. X is not live. Now, at this point, if we see, x is being used here. Okay. And what is happening is that there is at this point this is the value of x which corresponds to 1 and x is live here. Okay. Now here the thing shall be a bit clear if I take a little bit a different example. Okay, and we see what is the implication of a variable being live. Okay. Now see, suppose if I am having a value of x, means x is suppose live at this point. Okay, x is obviously live at this point. For example, we are having x at this point. Okay, and x is having the value as we said. Not here. Assume that x is live at this point. Okay. And as we know, x is having a value of 4. Now, if beyond this point x had no use, okay, if x had no use, then we could just, and we needed another register, okay, to store something else. Okay. So what we could have done is that we could have allocated another variable, say variable p, to this register and loaded the value of this variable of this queue to this register. Say it was, say, 100, suppose it was 100, which would have overwritten 4, and we would have not faced any issues because x the value of x was not used beyond this point. So since x is dead, means what is the implication is that we could have safely overwritten the value which was written to this register, means the content of register which corresponds to the variable x. We could have overwritten that, we would have faced no problem. But suppose, well, but here what is happening is that the situation is that b is being written the value of x plus 1. So suppose b was not here, suppose this was something else. So assume that this was not here, and or let me assume something like this. This is a different sort of thing. Suppose x is having a value 1 here. Oh, 1, say 1. Say 100. Now we are doing z equals to x into x, and again we are doing x equals to z plus 20, and we are doing say p equals to z6, and say d equals to 2 times p, or something we are doing. Then now then we will vary down. Okay, we are say doing say q equals to 2 into x. So what is happening here is that see, at this point x is not live, because let me change the color, it would be easier. At this point x is not live, because why? Because we are assigning a value to x. Had there been any old value of x, it was overwritten by this, so that with respect to that old value x is no longer live, and x is just assigned a new value. Now at this point, means at this statement x is redefined, and x is no longer live, means the old value is no longer live. And just at this point x is live. Why? Because z is using the value of x. Now at this point, okay, x is, this old value of x is no longer live. Why? Because we are overwriting x with something new. At this point, okay, x is live. Why? Because x is having use here. Now so what is x here now? X is 10,000. Okay, and this is 10,000. Correct. I hope I have done the calculations correct. Yes. So suppose we are having a register R1, and it is having a value x, and it is storing 1020 here. Since it is storing 1020 and x is live, now suppose we run out, when we see p equals to 6, we need to allocate which p is live here, we need to allocate a register for p. Now suppose we run out of registers, and since x is live here, we can't just overwrite the value of x. What we need to do is, we need to store this value of x in memory. Okay, memory location for memory, memory location for x, and then allocate this register to register, say to the variable p. Suppose the thing is it happens in such a manner that x has to be this concept is known as spilling. Okay, so this gets assigned to 6, and more work is done here. This one. Now again, when x is being used, so we have to again copy this back here. Okay. Now this main advantage of this liveness analysis is that if we are having non-live variables, we can directly overwrite these values and assign new values, allocate means assign this register to a new variable and have that value copied to that register without the need for copying back to memory. Okay. Now this is an example which I felt like sharing. I guess it shall uh, clear most of the doubts because this is quite a difficult notion. So at this point again x has been defined. So now one thing we should assume here, which I assume here, is that beyond this point there is no more definition of x. Okay, neither definition, neither use of x. Okay, this is something, and there is no loop sort of thing. Only this statement means this statement. A few three statements are there. That's all. Now, if x is one, what is happening is that x is being redefined. Before it there was some value, x gets killed. So at this point, x is dead. Okay. With respect to the previous value. Okay. Again, here we see that x is used here. That new value of x. Suppose we are assuming assigning a register to x, and then this is value. This is register R1, and it is holding the value of x, which is 1 currently, and this is the live value of x. Means this value of x corresponds to this 1, and this is live at this point because it is this value of x which is being used. Okay. Now at this point what is happening is that this value, okay, this value of x corresponds to this, and this value is a new value of x which is 20. Now assume I am making a bit of change to this program sequence. Assume that there is a statement, say a equals to x sort of thing beyond this. Okay, 4 statements are there. Now see this value which is which x is getting replaced by is 20 plus 1, which is 21. Okay. Now this old value of x is being replaced by this new value of x. So some people might be of the opinion that at this point, at this statement, okay, at this statement, x is live with respect, means before the execution of the write, means before this assignment. Okay, when the right hand side is calculated. Okay, so at this point this x is having the old value of x. Okay, now with respect to that, x is live, means with respect to the old value of x when the right hand side is considered, x is live. Now when this value, the calculated value is computed, means when this statement is computed, the old value of x gets replaced by a new value of x, and x gets replaced. Okay, means this assignment kills the old value of x. Now as per convention is concerned, I would go with the convention that x is dead here. Okay, this is usually the convention which is followed, I guess. So x is dead here. Why? Because after this statement is executed, okay, means partial execute, means when we are considering, we cannot consider that the statement is executed partially. So means different people have different point of view. Means they can say that when we are executing this statement, x is having the old value of x, which means that x is live at that point. That old value of x is being used. So, but if you see that means after the execution of this statement, x is getting replaced by the new value. So if we assume that with respect to this whole statement, okay, not this partial statement, means on the right hand side, the whole statement, if the whole statement is considered, okay, in that case x shall be dead. So that is the thing, x is dead. Quite simple. So that is the thing. Yeah. Now formal definitions are there. I am not going to those. I just try to show how means intuitively the thing can be done. Okay.